This is the practice problems of Pythagorean theorem. If you hear clicking, it's just my calculator. What I would do is, what you're doing is you're finding the missing side. You're going to look if the triangle, if it states it's a right triangle or it has a right angle, and it does have the right angle. So then the next thing I would do is I would decide whether I have two legs or a leg and a hypotenuse. Here is a leg, here is a leg, so I have a hypotenuse and a leg. I use the quicker formula. I'm going to put a subtraction. That's a square root. If I'm subtracting, I have to start with the longest side, which is the hypotenuse squared minus. So I'm going to do 102 squared, and I get 10404 minus 48 squared, and I get 2304, and then I subtract. This is still under the square root. And I get 8100. Taking the square root, that's 90. And I can double check because 90 is less than 102, and I know that it's a viable answer because 102 has to be the biggest. Okay, number 2. Here's my right angle, connected to the legs. I'm finding a hypotenuse. I just annotate it and say I'm subtracting. Do this. 68, the square root is 68 squared minus 60 squared. And 68 squared is 4,624 minus 3,600. All of that is still under the square root. I subtract. I get 1,024. I take the square root, and that's 32. And again, 32 is less than 68, so it is a viable answer. So this one, I can turn them upside down, I can crooked them, I can do lots of things to them. So here we go. Here is a leg, here is a leg, here's a hypotenuse. I'm subtracting 85 squared minus 68 squared. And I get 85 squared is 7225. And I do 68. And I get 4624. That's still under the square root. I don't take it out until I subtract. 2601, and the square root of 2601 is 51. And again, I look, and 51 is smaller than a hypotenuse, and that is an appropriate answer. Number 4, here's the right angle, here's a side, so I have two legs. So this time I'm adding, doesn't matter which one, but just to stay in the habit, I always do the larger one. Oh, I put a plus there, remind me I'm adding, because I have two legs, because the sum of the squared legs is equal to the largest one. So I get 96 squared, which is 9216, and 72 squared is 5184. Which is 14400. Take the square root of that, which is 120. Number 5, it's a little bit crooked, but here's attached to the right angle, here's attached to the right angle. Notice it looks like an L. That's add. the square root of 35 squared plus 12 squared, the square root of 1225 plus 144, 1369, and the square root of 1369 is 37. And then I look, and 37 is bigger than both the legs, so I'm good. This one, here's the right angle. Attached to the right angle are the legs. I'm not adding. Let me get my white out. I'm looking for a leg. And if I'm looking for a leg, I'm subtracting. Almost messed that up. That's actually the hypotenuse. Okay, so I do 60 squared minus 36 squared. Which is 3,600 minus and that is 2304. Make sure you take a square root, and that is 48. I have a leg. Here's a leg. There's the other leg. I'm missing a leg, but I have a hypotenuse. It's subtract. Square root of 95 squared minus 76 squared. This is 9,025 minus 5,776. $3,249, and take the square root, and that is 57. And 57 is less than my hypotenuse, so that's an appropriate answer. This one, I have a leg. Here's the right angle. That's the hypotenuse. So I'm subtracting square root of 75 squared minus 60 squared. And that's 60 squared and that would be 45. The instructions say find the missing and round the answer to the nearest tenth if necessary. These all came out integers, so we are fine. If you noticed how I at least set up the formula. So my minimum is you set up a formula and you give me the answer. That is my bare minimum of shown work. I'd like to see whether you're adding or subtracting. I'd like to see what numbers you are using in your problems.